This is Trend Following Radio, where great thinking comes alive. Nobel Prize winners, legendary traders, best-selling authors, and the pros that know what drive us irrational human beings. I am your host, Michael Covel. Not filtered, raw, honest. That's my passion. A true blast from the past. Animal weapons. This is one of my favorite interviews. I sort of forgot about it. I mean, let's face it, if you do 1,100 plus episodes, it's easy to forget about a lot of things. But I think you will enjoy this. If you recall it, or if you have never heard it, I'll bet a lot of people have never heard it. It's just a fantastic insight into something that maybe you instinctively recognized, but never really thought about. Again, that's animal weapons. I hope you enjoy my summer 2023 July rewind. I bet you did not think animal weapons would be the topic of my podcast today. But damn straight, it's all about animal weapons and how the evolution of animal weapons can not only tell us something about animals and what's going on with their evolution, what parallels can we draw for us humans? A fantastic connection, a fantastic parallel world, so to speak. My guest today connects those worlds. Douglas Emlen is an evolutionary biologist and professor of biology at the University of Montana. His research, among many research topics, but his core research provides insights into the development and evolution of exaggerated male weaponry, such as the horns found in scarab beetles. Think saber-toothed cats. Think the massive antlers on elk. I don't even recall exactly how I found out about Doug. But I saw this excerpt. I followed the trail, as I've done on so many of my podcasts. I went to his website. I saw this book he has called Animal Weapons. I read it, and I said, wow, this has got to be an interesting conversation. This man has gone down a very original path in his life, and not expecting to find what he found on his journey is extremely insightful for all of us. I hope you enjoy this conversation with Douglas Emlen.
Hello, are you there?
Hey, Doug, how are you?
I am well. I just saw your message about 10 minutes ago. I'm sorry.
No. I didn't know when you were on, so sometimes people like to start earlier. I'm easygoing about it.
So it's late at night your time, huh? Or 13 hours later, anyway.
Yeah, it's 9:15 here. 9:15.
Wow.
But I've gotten used to it, because I've been doing the podcast from first year from the States, San Diego, and then the last 2 years in Asia. So I've got to actually kind of like doing the nighttime podcast because like having a conversation with someone, you just call someone up and chit chat and.
So what moved you to Asia? I mean, I read up a little bit on you just a couple minutes ago. It sounds like you've only been over there a couple of years. Is it because of investments in marketing stuff?
I was doing a speaking tour in 2013, and it was supposed to be extended like 4 months. And when it was over, I was supposed to go back to San Diego, and I was like, I really don't feel like leaving.
Wow, cool.
So that's
I'm just
simple.
Curious because most of my research is on rhinoceros beetles these days, genetics and genomics of weapons and looking at rhino beetles. And a lot of the rhino beetle diversity is right over where you are. So we do field work in Japan. We have a lot of colleagues in Japan. We're talking about sampling populations across Asia. It's a part of the world I haven't been to. I mean, I've been to Japan for 2 days. That's it. All my other stuff is Africa, Central South America. So I'm really curious to see it.
I tell you what, in terms of Vietnam, I do know there's some biodiversity in areas of Vietnam that have basically been untouched. Even with all the conflict, believe it or not, there's just, mature, deep jungles that are just, land of the lost kind of place,
Yeah, I like those kinds of places.
I imagine you do.
Those are the places they seek out. So,
well, have you heard about the cave in Vietnam?
I have not.
They've just found the largest cave in the world. There's actually a jungle growing inside the cave where part of it collapsed. You should just Google largest cave in the world in Vietnam. It'll come up. It's insane. I mean, wow. For a guy like you, it's probably like a field day of things that no one's ever seen.
Exactly. When you get things that are isolated like that, you can get all kinds of diversity that's sort of unmatched anywhere else in the world. Neat. No, I'd never heard of it.
Yeah. So. And what's funny too is you talk about the diversity, and we move into this subject we're going to talk about today. And I was thinking to myself, and I didn't even know where to start. I've literally got like 7 pages of notes in front of me because you kind of are going wide and deep in a lot of different areas in animal weapons. But I thought for me, I was just thinking about the subject and where you ultimately start to draw parallels. And we're going to work our way back to the dung beetles to the beginning. But I was thinking, wow, America saw what happens during, for example, Pearl Harbor with the Japanese, kind of this, all the biggest ships in the world sitting targets. And then you saw what happened in terms of fighting in Vietnam, where you show up with all the traditional troops and traditional types of fighting a war. And then all of a sudden, the people they're fighting say, oh, we don't want to fight like that. We're going to cause you problems with a different style of fighting. And so I couldn't help but think as I'm going through your book on animal weapons, sure, the parallels are just right there staring at you in the face. I think
the parallels are everywhere. And these are the sneak tactics, right? I mean, right. These are the, if you can't play by the rules, break the rules. And asymmetric warfare like that, we were the asymmetric or the guerrillas during the Revolutionary War.
Right, exactly.
I mean, we refused to face the Brits on an open field of battle under conventional rules, and I think that this is the problem we face today as a military, pretty much wherever we go. I mean, we're dealing with pipe bombs and IEDs and suicide bombers and non-conventional warfare because nobody else has the infrastructure or the costly weapons to sort of match us toe to toe. And, if you want to talk sneaking, the problem, I'm happy to go off in any direction. And, the worst I'm going to do is piss people off with some of these ideas. But the things that scare me the most, and I don't know if I dare go there. Are you recording right now?
Sure.
Okay. Maybe I'll shut up before I go.
No. Seriously, go where you were to go. If you say something bad and we don't like it afterwards, we'll snip it and tell the audience that you said something too controversial.
Yeah, well, we can come back to the dung beetles and start with the biology and build up from first principles. It's just that once you start making these parallels, it's hard to stop. And so a couple of the scary things that emerged from this work for me, one of them was realizing that the political confrontations on the world landscape, if you will, that based on animals, we would predict would be the most dangerous, the ones that are the most likely to escalate, are matched rivalries between opponents that are sort of toe-to-toe, face-to-face, and relatively evenly armed and relatively sort of even in terms of economies and the amount that they can afford to invest into militaries. And so it makes some very quick predictions about hot spots on the globe where you've got rivals potentially with weapons of mass destruction at their disposal that are sort of going face to face. And it also makes predictions about the United States and who the most likely next big rival would be. And it's a country that I would personally prefer that we not enter into an arms race with. But all arrows point to China as the only other place out there that has the potential within the near future to match us toe to toe in this kind of a one-on-one face-off, this type of a duel. That, again, if we're going to take our lessons from animals, the lesson we learn is that's exactly the kind of confrontation that has the greatest potential to spiral out of control. So as a this isn't my realm, but it scares me when I look at the political stage and I sort of figure out what the chess pieces are likely to be. And the other thing I have to point out, you're talking about sneaky strategies, the sort of asymmetric things that we faced, the United States troops faced in Vietnam, and that the Soviets faced in Afghanistan, and that we face now in parts of the Middle East. The other sneaky strategy that nobody's talking about, or at least they're not talking about in this context, the one that really makes the hair stand up on the back of my neck, is cyber hacking. That is like the ultimate insidious sneak. And there's evidence now that again, it comes to all arrows point to China, but that there are hackers that are infiltrating our military infrastructure and our software systems that we need to fly our fighter planes or to navigate our aircraft carriers or to guide our missiles. And that's interesting because you can have these incredibly sophisticated, expensive weapons that are amazing in what they're capable of. And then you can have essentially a shoestring budget style sneak strategy that worms its way in there and completely undermines the effectiveness of these most state-of-the-art weapons. And there's all kinds of little hints that this is happening. But I don't think people are sort of connecting the dots that way, and it scares the daylights out of me.
In defense of China, to play devil's advocate, I would hazard a guess that they are not the only ones involved in cyber espionage. I'm sure we are too.
Point taken. Point taken.
I'm sure. And I tell you what, there's something else interesting too that I want to bring up, and then we're going to work back to the animals. I had a guest on last year, early '80s, won the Nobel Prize in game theory, a guy named Robert Aumann, and we got to talking about the Cold War. And he said, and we started talking about, and again, this goes right into your work, started talking about that, to avoid the war, you can't just yell peace. Okay. From his perspective, and this is a mathematical perspective, the game theory perspective, the John Nash perspective was you have to be prepared to fight. And then when you are prepared to fight, when you are at the point where both sides know you're prepared to fight, then there's no war. And he pointed out, he said, 40 years, the USSR and USA had bombers in the sky 24/7 loaded with nukes. And that kept the peace. Now, of course, you and I can immediately say, well, God, that really sucks that we had to do that. But then again, that's our world, right? Isn't it? I mean, you can't put the genie back in the thing again. And so I thought it was interesting but doesn't that parallel right with the animal weapons?
And again, I should just add, it totally does. And I guess I have to add the caveat that, I don't come at this from that perspective. I come at this as a biologist, and I came at this from a family upbringing that is very anti-war. In fact, on one side of my family, going back to the 1600s, they were all Quakers. I mean, I don't come at this from a rah-rah big armies perspective at all. But there I was pouring through the literature, looking at all these stories and animals, and that is exactly the conclusion that I came to as well. And it stunned me. I mean, it really shocked me that there I was as a scientist doing what we do as scientists and connecting the logical dots and drawing the patterns that we infer from the data that we collect. And that was the inescapable conclusion. And there are animal parallels. So
let me give you one animal. Let me let you start with one animal, and then we're going to work back to the beginning with the dung beetles.
Perfect.
Go ahead and talk about the fiddler crab and connect the fiddler crab to the Soviet and USA bombers in the sky 24/7, and they don't have to fight. And the fiddler crab is waving that big old claw, and generally they don't want to fight either, do they?
You got it. So fiddler crabs, I mean, they're the champions in terms of animal weapons. And most people can picture in their head at least roughly what these things look like. But just to put it into scale, these males have sort of two sets of arms or appendages coming off the front of their body. One of them is this little tiny one that they use to feed, and the other one is huge. It's this massive claw that they wave up and down and that they use in fights. And these claws are packed with muscle, and the males wrestle with these claws. The males invest 100% of their body weight in this weapon. That means they're doubling their body weight. They're producing a full copy of their body and carrying it around as a weapon. And by any metric you want to come up with, that's a staggering proportion of sort of material resources that are allocated to this weapon. So it's relative to body size, it's the biggest weapon of any animal ever. And these males are out there producing these huge claws. They're dragging these things around. These claws are expensive. They cost a lot of energy to make. They're dangerous for these guys to carry. They make them really obvious targets. They slow them down. I mean, imagine running with 150 pounds of gear stuffed in your arms. It slows you down. And so there's a price associated with these things. But these males invest all of this into the weapons because it helps them win fights over access to females. But where you're going with this is that these animals have these huge weapons, but they actually don't fight as often as you think that they would. They have tons of confrontations with rivals. Rival crabs face off in the sand by the thousands any given night on these beaches that are just covered with these crabs. But the males are waving them up and down as a signal. It's like this big billboard saying, I can clobber you. My weapon is bigger. And the males size each other up, and they line up against each other, and they wave their claws, and the guys with the smaller claws walk away. And they walk away for a good reason. It's because the size of the weapon accurately, honestly predicts the likelihood that the male is going to win. A male with a bigger weapon is in better condition, does have more resources able to pour into the conflict. Those are the guys that are most likely to win. And so what happens is all these fights end up getting resolved essentially peacefully, because the males will stand off and they'll wave and they'll bluster, and then the little guy walks away and there's no fight and there's no injury. Nobody gets killed in the fray. And so there are a couple, you see this to some extent in lots of animals with weapons, that the bigger the weapons get, the more visible they become as a signal, the more honest they become as a signal of fighting ability, the more effectively they function as deterrents. And when you get to the animals like the fiddler crabs with the biggest weapons of all, most of their fights, really most of the contests end up not being battles. They're not dangerous. The other animal that's worth mentioning is the caribou, because caribou have the largest antlers relative to their body size of any vertebrate, of any sort of warm-blooded animal with a skeleton on the inside. And these guys hardly ever fight. One of my favorite studies that I came across pouring through the literature was this study that looked at like 11,000 contests between rival males. Only 6 escalated into knockdown, drag-out battle. So yeah, these are weapons. Antlers are weapons, and they can be used to fight, and the fights can be deadly. But because the antlers make good deterrents, good signals of fighting ability, and because it pays to pay attention to those signals, these animals with the biggest weapons are the most peaceful. They hardly ever fight. So yeah, it was a little scary to extrapolate that to our modern world and to try to come to the conclusion then that sometimes the best way to be safe is to have the most effective, the most expensive, the most state-of-the-art weaponry.
It's counterintuitive.
It is. Now there's problems, right? That works in principle. And it may mean that most of the time you're safe. But even in the animals, if you look closely, there are still situations where the confrontations precipitate out of control. And in those cases, the fights can be really, really bad because these guys are heavily armed. And so we always run that risk too. The idea is that we may be safer on average, and the majority of conflicts may be resolved without fights because we have really effective war-making capabilities and it works as a deterrent. But it doesn't mean that it always works. And if it ever breaks down, then there you are with these sort of stunning weapons and facing the reality of actually having to use them.
Okay, I'm going to get you to pause in the breaks down part on mass destruction weapons, and I'm going to come back to that at the end. But right now, what I want to do first is tell you one more thing about me, and then I want you to define something as we start.
Okay.
Back at my house in Virginia, I actually have a scale replica of a Triceratops skull and a scale replica of a T-Rex skull. So I didn't go as far as you did as a little boy never growing up, but I've
came pretty close, actually. That's awesome.
I've tried to stay close that I have these scale replicas, the price of cars in my house. But anyways, here's where I want you to go. I want you to define out of the gate for people an evolutionary biologist, which is what you are.
Okay. That's not where I thought you were going to go with the Triceratops and the T-Rex skulls.
Well, we could come back to that, but I want you to define. I haven't got you to define you yet first.
Well, yeah, because people have a right to know who's this guy and why is he talking about politics and militaries and things like that. I'm an evolutionary biologist. What that means is I study natural populations of organisms in their element. So in my case, it's beetles. I've studied a number of different species of beetles. I've studied them in Central America. I've studied them in South America, in Africa, all over the world. And I'm interested in diversity in animal morphology. So for me, that means the weapons. I have a soft spot for these sort of extreme structures, and I study animals that produce things that are sort of outlandish and disproportionate and they make these animals look like they should tip over or trip. And you look at they're like a Triceratops. You look at an animal like that and it's like, how is that possible? Well, as an evolutionary biologist, we study how is that possible. I look at what these traits function for in the wild. And I look at why individuals with, in my case, bigger weapons might perform better or might reproduce more effectively than other individuals with smaller weapons. So we're looking at the forces out there in natural populations that shape the turnover, if you will, among individuals and cause some individuals to succeed more than others. We're interested in why certain subsets of the population do better than others and why populations tend to change over time in the directions that they do. Why do some populations change in a direction where the weapons get bigger and bigger and bigger, and other populations go in a different direction and the weapons disappear? as an evolutionary biologist, we're interested in the diversity. Why do some species have these traits and others not? And we're interested in the processes, the details of the things that unfold on the ground that cause those populations to diverge like that. And nowadays, it's a lot of genetics. I spend a lot of time looking at the genomes of these animals, looking at the developmental mechanisms that cause cells to grow into something like a weapon, and what kinds of physiological pathways and genes direct that development. And then if I want to know why one population has big weapons and another one has small weapons, I can sort of open the hood, if you will, look inside at what's going on in these animals, and we can start to get a sense, we hope to be able to get a sense for what types of mutations to what types of genes actually sort of spontaneously popped up in these populations that caused them to have different weapon shapes or sizes. And those animals then did differentially depending on their weapons. And these are the kinds of sort of historical events that unfolded to give you diversity in weapon form.
Doug,
so I wasn't ready for that question. I don't know if I articulated that clearly, but I'm interested in diversity. I'm interested in how populations change over time, why they change over time. And now we're at the level where we're really interested in the genes, the actual, sort of looking under the hood, the molecular biology processes that are unfolding that permit populations to change over time. In my case, it can be crazy things like animal weapons, but the phenomena that I study are no different than things that modern people studying evolution in medicine are studying. Why is it that a disease changes the way as it does? Why do we have to get flu shots every year? Because the flu virus evolves so rapidly that the vaccines we generate one year are ineffective at matching the strains of the virus that are out there the next year. That is one of the most rapid evolutionary phenomena anywhere. And so the kinds of things I study might be in the rainforest on beetles with horns, but they're actually the same things that people with the CDC are studying left and right to try to figure out where the next disease is going to come from and what direction it's going to evolve.
Pick an example of a particular arms race, an animal weapons arms race in your mind. Pick a fascinating one and lead me through look, I'm a nimble animal right now. I don't have any great armaments, but something starts to happen. So maybe there's a mutation in my brother. And my brother, he's got a little bit bigger something. And then maybe lead me through that process, pick an animal, and how that arms race starts to happen.
All right, I'm going to pick one of my favorite animals. It's one that most people don't spend a lot of their waking hours thinking about. It's the dung beetle. Everybody's heard of dung beetles. Many people have seen dung beetles. Most people haven't really thought about them, and most people are completely unaware of the kinds of weapons that some of these species have. So say you're a beetle, and if you're a male beetle, then everything in your world is about reproduction. I mean, your whole life flashes before your eyes, and whether you make it or not is entirely dependent on whether you're able to fight your way to access to a female. Well, if you happen to be a species of beetle that lives and fights inside a tunnel, and many of the dung beetles do this, right? They fly into cow manure or horse manure, whatever the particular type of dung might be. We study them in Africa. It could be elephant dung. You fly into a pile of elephant dung and you burrow through it. And then beetles tend to do one of two things. Some species carve a hunk of the dung off into a ball. They sculpt it into a sphere and they push it away from everything else as fast as possible. And just to get you into this scene, if you will, there's a lot of competition. You fly into a pile of elephant dung in the Serengeti, and you might have to face 50,000 rival beetles of all these different species that are all piling into this and all trying to carve that up and steal it and use it for themselves and use it to feed their own young. And so there's this intense pile of beetles all competing for this food source. So one way you get around the competition is you carve a ball and you push it away from everybody else as fast as possible. Well, if you do that, you're a male beetle, you carve your ball, you roll away with it, you're not going to get away unscathed. First of all, females are going to find the ball and go with you. That's great. That's like the whole story right there. If you can get a female to follow you with your dung ball, you get away from everybody else. You can mate with the female, bury that food, and everything is golden. Problem is all these other males are going to challenge you, and they're going to pile on top of you and pull at you and try to pull you off that dung pile. They're going to scramble around, and you're going to have 4, 5, 6 different beetles all fighting for this food source as you try to get it away. A different kind of beetle goes into that same elephant dung pile, and instead of carving a ball, goes into a tunnel underground. So females of these species excavate burrows like tubes into the soil underneath the dung. and they pull the dung down into the tubes, and that's their way to get away from the competition. Well, if you're that kind of beetle, you go into one of these burrows and you plant yourself at the entrance and you block that entrance and you make sure no other males get in there. And now you've got the female inside the tunnel beneath you, and you're blocking the gate, so to speak, and none of the other rival competitor males can get by. So in both of these cases, you've got males fighting other males to get access to females. But that one difference in behavior makes all the difference in the world. So now say your mutation pops up, your brother or you in this case, and you've got a little knob on your body that's a bit bigger than it was before, something that, sticks out like a little itty bitty horn. Well, if you're fighting in a big scramble, that's not really going to do much. You can't brace yourself very well. There's no way to use that little knob like you would to open the lid on a soda bottle or something like that. You can't use it to pry very well. You're scrambling around out in the open. And if anything, agility is going to matter. And if that little knob you produce is actually pretty expensive, you wouldn't want to be wasting any resources on it because it's not going to do you any good. If that little knob, that mutation arises that makes a knob on a beetle that's inside a tunnel, then everything's different. I mean, basically, they're both dung beetles. They're in the same place. They're fighting over females. They're doing the same thing. But in this case, because you're in a tunnel and because you're blocking the tunnel, a knob like that gives you an edge because now you can block that tunnel better. Another beetle tries to force his way past you, and you've got a hook now, literally like a bottle top opener that you can use to grab onto the edge of his sort of shield, the thorax part of him, and pry him out. And if that knob gets even bigger, you can use it like the bars on a jail cell to literally block off the tunnel so that nobody else can push their way by. So here's a situation where you can push into the sides of the tunnel with your legs and lock yourself in there. And you can use that knob on your head, that horn, to pry or to twist or to block the tunnel. And so in that situation, having a little knob makes a huge difference. And in that particular situation, the males that tend to have the biggest knobs or the biggest horns are the ones that have an edge. And that's some of the stuff that we did and a number of other biologists have done. We've been able to watch tons of fights. And if you're fighting inside a tunnel, the bigger bodied beetle and the beetle with the bigger weapons, those are the guys that win. So males with longer weapons win. So what that means is that animal, because of that knob, has a better shot at protecting the tunnel, a better shot at mating with the female, a better shot at siring lots of offspring because he got access to the female. The next generation of that population, then offspring are going to inherit alleles or whatever it is about the genotypes of these animals that cause there to be that little knob. And that's going to be a little bit more common in the population than it was before. And those kids are going to do really well because they've got the bottle top opener. So when they get into fights, they do better than animals without that. And the next generation, their progeny are going to be even more numerous. And the next generation after that. And pretty soon, the population evolves. It turns over so that everybody now has that little knob. And now, say somebody comes up with a mutation that has an even bigger one. So now everybody's got a knob of some sort, but some of these males have really big ones. Those guys win over the ones with the smaller ones. Their kids are the ones that are the most numerous, and then their kids, and then their kids. And then very quickly the population moves, it sort of ratchets up a notch till the weapon's a little bit bigger.
I think of something else that comes up in the human population. And being in my mid-40s, I'm old enough to have watched the maturation of all the pro sports leagues, etc. And you don't need much of a pulse to be able to recognize names and the number. I don't care whether you're white or black or what sport you're in, but the number of guys that were pro athletes when I was a teenager, my early 20s, that now are starting to have kids that are superstars as pro athletes. You know, look, there's nurture, there's nature. Not everybody's, not Michael Jordan, not every one of his sons has become the next Michael Jordan, but clearly there's something at play, and we don't talk about it. We don't talk about it.
I didn't prep for this, and I'll get the details wrong, but there is. So there's a number. I mean, so studies of human genetics are just, they're incredible these days. They're moving spectacularly rapidly, and we have more genomics resources for sort of understanding things at a genetic level in humans now than for anything else out there, for obvious and good reasons. And so what people are doing is they're scouring through the genome looking for, you know, mutations and variations in particular alleles of particular genes that seem to correlate with disease traits or with other types of traits that people are interested in. And they begin by trying to sort of form an association. They look for sort of a statistical match between a particular variant of a gene and being a really good athlete, for example, or having a propensity to a certain disease. And once they start making these associations, then the geneticists and again, evolutionary biologists can zoom in and start looking in mice and in other model systems. What happens if we perturb this gene? Do we change the traits that we care about? And they can start to come up with functional links between particular genes and particular traits. And I'm not going to remember the names of the genes in this case, but yes, there are studies now that are showing that there are particular variants of certain genes that affect the way your cells use oxygen, that make you more efficient. So for the same amount of circumstance or the same amount of air, some individuals are more efficient at using that oxygen than others. There are alleles that affect muscle properties. There are actually logical genetic underpinnings to why some people have really, really good athletic performance. And it's not as simple as that, right? I mean, the kinds of things that make a sprinter are different from the kinds of things that make a marathon runner. And you look at a football field and you look at the body size and the muscle build and the differences among individuals. A lot of that is not inheritance of particular alleles. It's training and it's diet and it's other things that people do. But you can see pretty quickly that there are different types of traits that are specialized for or that perform especially well for particular functions, whether you're a running back or an offensive lineman. And again, some of that is going to be driven by training and by diet, but a lot of that, I think we're realizing the kinds of sort of predispositions to be really small and light and fast, or to be really big and bulky and wide, those kinds of things I won't be surprised at all if we can start to find really clear genetic underpinnings for. So no, there are loads of things you can start to look at in people where we can start to figure out, at least at some level, what genetic variation sort of predisposes people. But I want to be clear about something. If you're going to, that's again, this is, I'm going the directions you're taking me here, and that wasn't.
I'm not going anywhere. I'm just wandering around the playing field. I'm just looking under the hood and seeing what's there. What do you mean? I'm not leading you anywhere.
No, I didn't mean it that way. I just meant that I would have done my homework and I would have actually had the names of the genes in question.
Okay, listen. Okay, here's where I want to go next. Okay, so
I want to make one thing clear though. What we're finding, it's not as simple as saying, oh, I have a gene for this trait and therefore I'm going to have this disease, or I'm going to be, an incredible athlete. What we're learning is that the interesting biology is at the interface of genes and the environment. It's the way that particular alleles in your genome interact with the diet choices you make or the lifestyle choices you make. There's actually an interaction between those two. And so what happens is you might inherit an allele. You might have a very strong family history for cancer or for alcoholism. It doesn't mean you're going to be an alcoholic or you're going to get cancer, because there isn't a gene for this. But what it means is, because of the alleles you inherit, if you were to line up 100 people and expose them to the same sets of environmental circumstances, some of them, maybe you, because of the allele you inherit, are going to be more likely to develop cancer in response to those situations than others. So there's sort of an inherited predisposition or a propensity towards a particular condition like cancer or alcoholism. If you don't drink, you can't become an alcoholic. But you line up 100 people and you give them the same sort of alcohol regimen, and not all of them are going to become alcoholics. Some of them are. And we can start to explain why some people have sort of an inherited predisposition that makes them more likely or more prone than others. So yeah, there's some very exciting genetic studies coming out there, but it's important to put them in context and understand that it doesn't mean that there's a gene for the trait and, oh, I inherit this allele, I'm screwed. But it does mean that you might want to change your behavior. You might want to be aware that in my case, it's heart disease. I have a family history of heart issues. Knowing that helps me make different diet choices than I would otherwise. And it helps me exercise more than I otherwise would. It makes it a higher priority for me because I know that I have an inherited predisposition towards things. So that's the way to think about it. And it can be transformative and constructive.
Clarification well taken. Okay, so here's where I want to take you back to.
Let's go back to Beatles.
I'm going to take you away from Beatles for a second to something a little more sexy.
Wait a minute.
Listen, I can't convince you that Beatles aren't sexy. I know how much time you spent with Beatles, okay? I understand.
Beatles are the triceratops of the insect world, and you told me you love triceratops. So.
Go with me for a second. So we've talked about the arms race and how an arms race can happen in the beetle population. But then eventually something like an arms race, as you state, it can run its course. And I think it'd be an interesting example because this was one of my favorite animals as a kid. And not until I was an adult, and frankly, not until I started doing this podcast, am I going back and reading about, I think was the technical name would be Smilodon. Would that be correct? So I going back and understanding that big old saber-toothed cat that I thought was so cool when I was a kid was kind of, not a sleek body, not a big runner, and was a guy that basically his front two teeth had gotten so long, he just hung out in a tree and wait for a mastodon to come by, right? Explain how an arms race can start to run its course with something like the saber-toothed cat.
Okay. Yes. In the situation I set up with the beetles, and that's relevant to the fiddler crabs and it's relevant to caribou, these are situations where the weapons are borne by the males, and the males are using them in battles over access to females. So the context or the backdrop for all of this is competition over access to reproduction. That's the currency that matters. And so the weapons tend to only be in the males, and they get used in this certain type of a contest. And that is the most common sort of natural scenario that leads to extraordinarily rapid arms race evolution of ridiculous weapon sizes. Sexual selection is what it's called when males compete for access to females, or when members of one sex, it can go the other way around. Members of one sex, male or female, compete for access to the other. That's sort of the most pervasive, most widespread phenomenon that tends to lead to extravagance and to the evolution of these things that are absurd. But as you point out, Smilodon, so the saber-tooths, are another. And that's not a situation, the big canine teeth in these guys, and they're amazing. And you said you have a Triceratops in your house. I have a life-size replica of a Smilodon or a saber-tooth skull on my desk in my office. I love it. I walked into that assuming, of course, it works like all these other weapons. Surely those big teeth are just in the males, not in the females. And surely it has to do with fighting over access to females. I was wrong. That's not true. And at first I didn't believe it. I was going through the literature like, this can't be right. How come they're not talking about sexual selection? How come they're not talking about male competition? And I finally had to contact some of the paleontologists, and they're like, no, you're wrong. Everybody had the big teeth. Males had the big teeth. Females had the big teeth. These were not structures used in competition for access to reproduction. They're used by predators. And that actually threw me for a loop, because when you look at predators, most predators don't have really big weapons, and it's for a pretty obvious reason. They slow you down. They get really awkward, and you can't run fast, or if you're a fish, you can't swim fast, or if you're a bird, you can't fly fast. You can't move fast if you're carrying this big, clunky, awkward weapon around. And so if you're a predator, that's usually the end. I mean, if you can't catch your food, it doesn't really matter how big your weapons are. And so the interesting thing that the Smilodon, where it's sort of this thorn in my side. It's like, here's this animal with an incredible weapon, and it just didn't fit the pattern. And for me, it was one of those epiphanies when all the pieces finally clicked into place. And I was reading this paper about the saber-tooths, coming at all the specimens they'd gotten in the La Brea tar pits, and they're talking about what they think these animals did. And you hit it on the head. These guys were not able to run fast. They were awkward. They were thick and heavy and gangly. And if you think about their faces, they couldn't have run fast. Their heads are squashed backwards. So these teeth sort of project forward. They can't even look at where they're going. So these are clumsy animals. And these people in this little paragraph in this paper say, well, we think they were ambush predators. And that was it. That was like, boom, everything clicked into place. And I started realizing, my God, an ambush predator, they don't have to run fast. They're not a cheetah. They don't have to chase down prey. They sit there and they wait for the prey to come to them. And that's a fundamentally different hunting strategy. But as soon as you do that, you change the game, because all of a sudden it doesn't matter if you're awkward or you're gangly. What matters is, can you catch that prey really quickly? And in a lot of these situations, big weapons are better. And so in the case of the saber-tooth, they think that these guys hung out on trees. They hung out up in trees, and they dropped from trees onto unsuspecting prey. And the best guess, as far as I know, is sort of lumbering juvenile mastodons and mammoths. So you've got your little baby elephant walking by, and all of a sudden this thing with like 10-inch daggers drops out of the tree, plunges those things into the back of the neck, and kills the prey. They don't have to run. They're not a cheetah. All they have to do is drop onto their unsuspecting prey. And so once that sort of piece to the puzzle clicked and I started looking around, I realized this is true everywhere. My kids love Finding Nemo. Remember the viper fish in Finding Nemo with this? It's just basically a mouth with huge teeth that was down in the deep sea. That was a cartoon character, but it's a caricature of true to life viperfish and anglerfish. There's a whole suite of these deep sea monsters. They're ambush predators. They use little dangling globs of light as a lure to pull the prey into them. They don't have to swim fast. These aren't tuna. These things sit there and they wait till the prey come to them, and then boom, they grab them with these massive jaws. You see the same thing with alligator gar with these long jaws. You see it with praying mantids. So yeah, you hit on something there. There is a whole separate context out there in nature that can lead to the evolution of extreme weapons. And it's when predators that presumably used to be the traditional run them down, chase them down predators change their behavior, and they start adopting a sit and wait or an ambush tactic.
Yeah, no, I was thinking of another example to throw at you about just something from my world that I think parallels with this notion of an arms race. And if I look at the trading world, for example, so all the rage right now is for people to have faster and faster trading. So I don't know, they want to trade the speed of light. So it all becomes very resource dependent. I mean, servers on top of servers. You have to get closer. There's been a lot of books about this. You have to get closer to the exchanges, et cetera, et cetera. Now, that's one way to think about it. And there's a huge arms race there. However, there is a very
I never thought about that.
there's a very sizable population of extremely successful traders that go just the opposite direction. They maybe trade what we call a weekly bar. So they trade one day, the closing price of the stock market once a week. And they only make their decisions off the closing price of the stock market once a week. So all these other guys are out there trying to trade at the speed of light because they think the faster they can get ahead of everybody. And there's other people that are saying, hey, hold on. We don't want to have all those resources. We don't want to have.
Can I ask you a question about that?
Sure.
I'm making an instant prediction based on what you're saying. These people that take that plan B, they don't play by the rules. They're not investing everything in these really fast servers. Are they saving?
You already
resources?
know.
Are they? I mean, are they?
You already know who wins.
Some staggering price.
Here's the thing. Look, the high frequency guys, the ones that have got the rigged game, of course they're making money. Okay, but it's kind of like a rigged kind of thing, and who knows if that lasts, right? Maybe that's something for right now. But you're thinking right that the people that are using less resources are a little more nimble, and maybe their quality of life is different. But yeah, the people that kind of look at less data and a longer time horizon can do just as well, if not better, and they don't have to stay in that arms race of the fastest servers and the fastest connections and all that kind of stuff.
I love it. I've never thought about that example. I love it, and it's a perfect fit. This is exactly what you see in animals. So you get the biggest males that are investing just obscene amounts of resources in these weapons, and for the biggest of the big, the males with the biggest weapons, it's worth it because they win and they are able to get access to the females, and they might get access to lots of females, and all that time that means there's all these other males that aren't getting anything at all. So to the victor go the spoils, in a sense, and if you can play that game with the best resources and the biggest weapons and win, you do really well. But these males are investing enormous resources in these things. And so if you look at some of the studies on antlers and elk or in the deer family, these guys are leaching so much calcium and phosphorus in order to make the antlers that they're pulling it out of their own skeletons, and they're going through this sort of brittle boned seasonal form of osteoporosis just so that they can shunt everything into the production of the weapons. I mean, it's deficit spending. They're depleting their own reserves that they need to survive to make these weapons. And you look at some of the beetles, and they're putting so much into these weapons that they're stunting their eyes, and their wings are smaller and their testes are smaller. So they're they're doing all this so they can mate, and then they can't even produce as much sperm because they had to shunt resources away from their testes to make these big weapons. So you're paying this huge price. And so what do you do if you're not the biggest male in the game? You can pour all these resources into this expensive technology, so to speak, the weapons, but you're not going to win. Go the opposite way. And that's what they do. They ditch it. They stop producing the weapons. They shunt everything into something else and they adopt a plan B. They sneak, they do something else and break the rules.
Go to the octopus example with the color changing and the smaller octopus male that gets around these limitations that we're talking about of the alpha. And still the octopus is not the alpha, but he's figured out a way around the system.
Yeah. So this, all right. I love this story. So first, just to connect the dots though, the beetles that we just talked about, you're in the tunnel, you're a big beetle, you've got huge weapons, you're fighting to block the tunnel. What happens in the beetles is there's little males that don't even produce the horns at all. They've got really big testes, really big genitalia. They are good dispersers. And instead of fighting, they dig a little side tunnel and they mine their way in underground and they're able to get around the big guy guarding the gate. And they can get into the tunnel beneath them by mining their way in. And then they can mate with the female on the sly. So they're not producing weapons. They're not fighting. They're not investing in armaments or fighting or any of that stuff. And they sneak around to do an end game and they get in. So the one you're mentioning is one of the slickest of these. And it's related to the octopus, but it's the cuttlefish actually. And what they do, these guys they're really quick at changing their body color. So they can go up against sort of rocks on the bottom of the ocean and change in a second or two and match that pattern so that they just blend, they vanish into the background because they're so good at hiding. And they're sort of mimicking the stippling pattern and all the colors of the pebbles and the gravel and the stuff beneath them. And so these are animals that have extraordinary abilities to change color. And so what you're getting at is in the mating season, and again, this isn't my work. This is just an incredible literature that's out of people like Roger Hamlin that have done this stuff. But what they find is that these cuttlefish, the big males, during the breeding season, they turn into something that's the underwater equivalent of a peacock. They produce beautiful purples and greens and this rich sort of tapestry of color on their bodies. That's this big display to attract females. Well, if you're a little guy, you're not able to produce as big or as bright a display. You're not going to win at that game. You're not as attractive as the biggest, sexiest guys out there. What do? So they cheat. And what they'll do is they'll mimic a female. They'll put on a color pattern that makes them look like a female. And then they can swim right up to that big displaying male. The big guy's up there with his billboard and he's got a female right next to him that he's mating with. The little guy, by pretending to be a female, can get right up to that big male. He's not going to challenge him or push him away because he looks like a female. He can get right up in there and he can actually sidle his way, wiggle his way in between the male and the female while they're courting. And then as soon as he gets in there, he's slid right in there so that he's in between the big male and the female. He changes his color again. And on the side of his body where the male can see him, he still looks like a female. But the other side of his body, the side of his body that the female can see, he changes into a really bright colored male display. So he's like a two-toned animal, and the female looks and sees another male. The male that he's literally right up against looks and sees a female, and he's able to slide in there and mate with the female on the sly by cheating, essentially, by breaking the rules and by playing around with color in a really clever way.
You know, if you bring that back to my example, I was talking about trading, it's the creativity and the industriousness to say, okay, even though maybe the deck is stacked against me, there's a workaround. And that's exactly what you're talking about, the cuttlefish. There's a workaround. The deck, I mean, because you hear all these people in life, they say, oh, the deck's stacked against me. I didn't inherit Shaquille O'Neal's gene pool. I can't do this. I can't do that. There's always a workaround if you want to spend the time, right?
Yeah. And that's how it works in most animal populations too. You know, there are a small subset of individuals that have it all. They're born into wealth, so to speak. They've got really healthy, dominant parents that they're born with better immune systems, better access to nutrition, better territories. Everything is stacked in their favor. But it doesn't mean that the rest of the animals in these populations give up. They find workarounds. And there are so many neat examples of workarounds. You asked at the beginning, I'm an evolutionary biologist. What do I do? Well, one of the things that's really fun to do as an evolutionary biologist is to look at all the ways that animals have solved this problem and to figure out the kinds of crazy, quirky workarounds that these animal populations have stumbled on. Because there's some fun ones, like the cuttlefish. I mean, how cool is that?
Yeah, it's awesome. I mean, it's crazy. The parallels are crazy because I caught something in an article where you got some good bit of press somewhere and I caught it and I reached out to you and I was like, I had not read your book. I had not bought your book yet. And then I started going through it. I'm like, man, this is crazy. The parallels are just, it just jumps off the page if you're like, wow, you're forced to, I mean, I'm thinking movies somewhere. I don't know. But, okay, I've only got you for a little bit more here.
Sure.
Let's wind down to the arms race. And two things that I want to put in people's head to think about, for example, battleships. Battleships, there's no need for a battleship, or there hasn't been for a long time, but they looked great. You can think about the British Empire, trying to manage, was it 25% of the world's population? It becomes unmanageable. But where I wanted to, just getting people to think about some of the topic areas that you go into, we can't go into everything today, but the last thing I wanted to end with was going back to what we started with, was basically how they call it in war games, thermonuclear war, whatever it is. Okay, so the way that it worked during the Cold War, you had two powers in a nuclear detente. Okay. So, but what happens, and you kind of hint about this in your book, what happens if there's more than two actors, there's 5 actors, there's 10 actors, and then let's say that those actors don't all have the same cultures and the same understandings. In hindsight, the leaders in Moscow and the leaders in Washington, D.C. probably had very similar outlooks to some degree. But what happens if nukes are the final toy to be used and there's no coming back? What happens if too many actors have nukes? And I think I know where you ultimately are going to go with that thought. And I think it's hard for people to disagree that there's probably going to be a point in time where something bad happens.
Yes, it's a fairly scary conclusion when you follow the logical train that I set up in this book. And so I'm trying to think how to do it quickly and how to get where you want to go.
You can talk as long as you want.
Oh, I can, because you brought up a bunch of things.
Go ahead.
First of all, just to make the point, again, I come at this from biology. What I did is I stepped back from having worked on beetles, and I went through the literature, and I started looking at examples of arms races in lots of different kinds of animals, in everything I could find. And I did it, first of all, because I wanted to tell the stories of these crazy, these are wonderful, amazing, bizarre animals. They look like freaks of nature. And I like that. I wanted to understand what makes them tick and why they look and act the way that they do. While doing that, it became increasingly clear that whether I was talking about a little moose fly in New Guinea or a mastodon, the stories were the same, that these animals were incredibly different in every aspect I could think of their life, where they lived, what they ate, how big they were. Everything they did was different except for the weapons. They all had huge weapons. And the more I looked, the more I realized they all had these weapons for the same reasons. So the same kinds of circumstances, the stars had to align in exactly the same way in order for these populations to launch into an arms race. And so once I started realizing there is sort of a common theme, there's a core set of criteria that can trigger an arms race, then I started looking much more closely at the arms race phenomenon. What happens once it begins? How does it unfold? Why do they end? And all of these things turned out to be parallel across these species too. Around the same time, my editors are like, hey, you got to look at human weapons too. And my first reaction is, no way, I'm a biologist. But they kept saying, no, I think there's something here. Dig a little deeper and look. And I started reading the military literature. And that's when I started getting really blown away, because I realized that there are everything that was sort of a common element that could explain an arms race in an animal also applied when we started looking at our own military technologies. And that was the sort of realization that took this book to the next level and took me to the next level. And I started going crazy, pulling all these things together and trying to look for parallels and trying to figure out what starts arms races in our military traditions. Is it the same kinds of conditions? And once the arms races start, are they going to unfold in the same way? And when they collapse, are they going to collapse in the same way? And the answer I kept coming back to is yes, it's exactly the same. And then right around the time I was starting to get excited, but I was still nervous because I'm not a military historian, I stumbled on the work of a military historian, Robert O'Connell, who writes, in my opinion, brilliant sort of analyses of military history, who's gone into arms races and asked exactly the same questions, and he'd come to almost exactly the same conclusions. So here's a military guy with specialties in arms races and military who's looking at biology for parallels. And I'm a biologist looking at the military for parallels, and we're meeting in the middle and coming to astonishingly similar conclusions. And that's when I realized, my God, this is real. And so I started running with that. And what this book is sort of portraying how this process unfolds and trying to set up these parallels. You mentioned battleships. So battleships are relevant for lots of reasons. But one of them is the thing that starts the arms race, this kind of one-on-one interaction, turns out to be, I haven't really talked about it here, but one of the things that's this crucial prerequisite for the competition type, not the predator arms races, but the male-male competition, the battle type arms races, is a duel, a one-on-one confrontation between rivals that unfolds in a very predictable fashion. And that predictability is essential, because that's what makes it cost effective to invest in weapons. If the male with the bigger weapons really is going to win, then you, by God, want to have the biggest weapons. If the fights aren't predictable, if there's a huge stochastic component to it, then it's not worth spending a lot to build a weapon, because it might not matter. It might not determine the outcome. And so explaining arms races meant explaining what are the circumstances where the outcome of fights become the most predictable. And once you could identify that, you could explain when weapons got big in animals, and you could explain when weapons got really extravagant in people. The problem is, and you sort of touched on it, is that the crucial condition that makes these expensive weapons worthwhile is this predictable outcome, this sort of one-on-one contest. And when you start getting 3, 4, 5, 6 different animals in the fray, everything starts to break down. It gets really chaotic and really unpredictable and really dangerous. And so the dung beetles, where they carve the balls and they're all wrestling and tussling around on the surface, those fights aren't predictable. It's not worth having a weapon. And none of the ball-rolling dung beetles ever have weapons. Only inside the tunnel, where the males fight one-on-one. In a tunnel, you have to fight one-on-one, because you have to crawl into the tunnel to confront a rival, and only one rival can fit in the tunnel at a time. And you got to walk into the tunnel, so you face your opponent face to face, one-on-one in a duel. So being in a tunnel makes it predictable and consistent, and that can lead to arms races. So when you start talking about big weapons in politics and landscapes, if you've got a duel like the Soviet Union, the USSR, and the United States locked head-to-head, that's a one-on-one showdown. That's a predictable type of escalation that's just like what we see in animals. When you start getting a whole lot of other states in the game, the numbers of degrees of freedom, the ways that this thing can play out become sort of astronomically complex. And one of the conclusions you come to is the really big weapons aren't cost effective. They're not worth it in that kind of contest. It's too dangerous and it's too unpredictable. That sort of safety factor that you get from deterrence won't work when it's too complicated. And there's one last thing. I know I'm rambling for a while here, but one more point I want to make on that. One of the other things that comes out of this parallel, this logic, is that, you know, this thing that you talked with me about a little bit earlier today, why are we safer with big weapons? Well, we're safer with big weapons if those really big weapons are honest signals of who's likely to win a fight, and if we're sort of in a one-on-one showdown with a rival who has similar armaments that are also really big and really effective. In that situation, it doesn't pay either side to escalate into battle, because we both know we'll lose. That mutually assured destruction phenomenon is real, and it can lead to a stalemate, and it can lead to peace. But it requires the biggest, most deadly weapons also being so astonishingly expensive that only the superpowers can afford them. That's the reason there's only two facing it. They're the only states out there that can afford to play that game. And that's what keeps it simple, and that's what keeps it predictable. The things that we're facing now aren't like that, because the weapons of mass destruction that were those state-of-the-art, astronomically expensive weapons during the Cold War aren't now. There's tons of nuclear weapons out there that are rotting away in storage sheds, that are, you know, and we have biological weapons now that are really dangerous that you can build for a couple grand in a basement. And so the weapons with the most killing power aren't the most expensive now. Lots and lots of organizations.
Let me interject one that I think, just to play devil's advocate for a second.
That makes it very scary, because now it's a one-on-one showdown. It's not predictable.
But here's
shouldn't work.
Here's an interesting one that I think if we put ourselves in the shoes of the average Ukrainian today. So I believe in the early 90s, Ukraine had the third biggest stockpile of nukes, right? And so the USSR breaks up. They've got the third biggest stockpile. And the deal essentially was, okay, give up all your nukes. You know, basically NATO will protect you, or we won't let anything happen. And so Ukraine gives up their trump card, so to speak, and then boom. I mean, I can't think there's any state actor right now that will ever believe, after watching what happened in Ukraine, they will never believe on a state actor at that level that a nuke is not a deterrent. They won't believe it.
But how is it a deterrent when too many players on the stage start having these things? I mean, again, again, if we're going to take lessons from animals, deterrence only works in very specific situations. And they're ones where the outcomes are very predictable. And that predictability comes from these sort of one-on-one showdown matchups. And in a landscape where a dozen or 24 nations have weapons of mass destruction of one sort or another, deterrence shouldn't work in that kind of situation.
Okay, but if we put ourselves in the leadership of Ukraine, and they give up their nukes, and they're told they're going to have protection.
I hear you.
Nobody's going to ever believe. No state is ever going to believe if I give up my nukes. And of course, I mean, look, it's insane. The whole thing's insane.
This is the problem. So any state looking at itself, which is what states have to do, is going to come to the inescapable conclusion that they're going to be safer with these types of weapons of mass destruction than without. For the logic that you're referring to, nobody's going to screw with us because the consequences are too dire.
Yeah.
Fine. But when you get too many states that make that independent assessment and that then ratchet up to that level, the collective effect on the global landscape is pandemonium. I mean, it's unpredictable. It's not a one-on-one showdown the way we had in the Cold War. It's a much more complex,
it's something different
thing, and that's where I am so out of my element. I'm a biologist again. I mean, let's not forget I work on beetles, but that's where the logic that made so much sense, that brought so much clarity to understanding our past by looking at animals, that logic begins to dissolve. And I ended up no longer being comfortable making predictions about where we are today, because the landscape that we're sitting on today literally scared the daylights out of me. I mean, if I'm going to draw conclusions from the animals, the conclusion is, wow, this is a spectacularly dangerous situation that we're in, partly because it's a more complicated landscape without that predictability of a one-on-one showdown, and partly because the technologies, the legacy of the Cold War, like it or not, are weapons with a capacity to kill on a scale that's unprecedented. There are no animals with weapons of mass destruction like that. There are no animal parallels of a weapon that is so dangerous it can't really ever be used anywhere. I mean, we just don't have examples of that in the animal world. And so once you raise the stakes that high, you're getting to a point where these weapons are so dangerous, they really can't be used ever, anywhere. And there is no precedent. I mean, again, I mentioned things like fiddler crab claws and caribou antlers. These make great deterrents. And in the caribou 11,000 contests, only 6 escalated to full battle. But you know what? 6 of them did escalate to full battle. These things still do function as weapons occasionally. And we're talking about technologies that we've inherited now that are so bad that we can't let that ever happen. And there is no precedent for that in nature. It never happens in nature. They always get used at some point. And that's, I guess, where I start getting the chills up my spine, start getting scared.
It's funny. I don't necessarily get the chills. But not because I don't think it will happen. I think the chances are, maybe not in our lifetime, but the chances are at some point in time, if too many state actors have nukes and some of those state actors are not as well funded or this or that, something's going to happen. I mean, there's no doubt about it. I mean, if somebody could do 9/11, they can. I mean, look, if they had a suitcase nuke on 9/11 and they had it in New York City, they would have used it. They would have used it. Of course they would have used it. Why not? That's the way they were thinking.
You're not helping me feel better here.
How can I?
So where are you going with this? You're right. You're exactly right. This is why I'm scared. Because if you take something like that, to put that into context, that's a sneak strategy. We talk about sneaky male beetles getting in around the big fighting male. With a superpower like the United States, with the conventional arsenals that we have, the options that are on the table for most of our opponents are the little sneaky male strategies. They break the rules. They do something unexpected and unorthodox, and they don't fight us fair fights on a level playing field. And when you start taking sneaky strategies like that, they happen in every animal system out there. They've all got sneaky males of some kind or another. That makes perfect sense. But it doesn't really affect the integrity or the profitability, if you will, of the armaments of the big males, because it still pays to be the biggest male most of the time. But if the sneaky males start doing too well, if they start stealing too many of the matings, then you run into this point where all of a sudden these big guys are producing these big expensive weapons and they're shunting tons of resources into it. And then instead of getting a return on their investment, their return is being eroded by these sneaky parasitic guys that are sneaking in and breaking the rules and cheating and pulling away all the benefits. And so they're not paying the cost. So these big guys are paying this cost and they're no longer getting the benefits. You reach this point where an arms race can collapse because it's just not worth it anymore, because the sneaking strategies do too well. So most of the time, the little sneaky strategies they're not that effective. Yeah, they can do harm, but they're not going to completely topple the regime or win in an outright sort of black and white sense of the word. They're just there being a hassle. But if you start getting sneaky strategies with weapons of mass destruction, if you're talking a suitcase bomber with a suitcase nuke, now you're changing the stakes here. You're talking about sneaky strategies with the potential to inflict catastrophic damage. And again, there is no in the animal world, that would collapse an arms race. Is done. It's like, it's not worth having big weapons anymore because they're not going to help you anymore. But I don't know that you can make that parallel and extend that logic. I
would start doing yoga and meditation, because it's not worth worrying about something that will surely happen at some point in time.
But I will tell you that as an evolutionary biologist, it's been a pretty wild ride. It's fun starting to look at the landscape around us today. And I like history, starting to look at the past and thinking about it in this new light.
Yeah, it's awesome. It's awesome.
If you want to end on a high note, that's an intellectually rewarding and stimulating exercise. It's a great way to sort of improve our understanding of the natural world. I live in Montana. I've got elk behind my house, and we've got, I live surrounded by animals with crazy weapons. And a lot of that diversity makes more sense now. And I love history. And so reading the history, a lot of the arms races in the past make more sense now. So the parallels are really rewarding. It's just awesome. When we start getting to where we are today, that we're dealing with a landscape that has no precedent, where things start getting both scary and really unpredictable.
I'll give you a high note change of subject. So I was jotting a last note down here about my world, and I was thinking to myself, okay, there's no guarantee that all the expensive resources that can give you perhaps a predictable, short-term, high-frequency trading advantage, there's no guarantee that all that stuff's going to work. But less money spent and that nimbleness sounds a heck of a lot more interesting to me. I love nimble. Nimble should be the topic of our conversation. I mean, I just love nimble. The idea of being nimble, I'd rather be a nimble character as a human being in this world right now than stuck. Now, I'm just talking from myself standpoint.
It's so funny. I mean, I study all these animals with these monstrous weapons, and we all like to identify with the biggest bucks with the biggest racks of antlers on their heads. But, most of us don't fit that bill. And I'm probably more of the sneaky male strategy myself, I suppose. Nimble is good. I'll agree with you.
Hey, listen, Doug, it's been fun chatting. Where can we send people? The book is on Amazon. I know, because I just bought it.
It's also through Henry Holt and Macmillan. They have a page. It's called Animal Weapons, The Evolution of Battle.
Where can people find out more about you online? You've got a bunch of stuff online. You've got a lab online, all kinds of stuff.
I'm a biology professor at the University of Montana, so I have a research page and a faculty page that's really easy to find. I don't know if we have a Wikipedia page yet, but we may have one soon. But again, the other way to find me is just to search for Animal Weapons, The Evolution of Battle, and there's an author page and there's information there. Now, this has been a pleasure. Thank you for chatting.
Thanks for it's one of my most unique podcasts yet, I'm sure. Thanks,
I hadn't seen the parallels with trading until you brought it up, but I think there's a pretty cool parallel there.
Yeah,
I had never thought of before. So thank you for that.
Hey, take care, man. We'll talk again, hopefully in the future.
All right, you too. Take care.
I see a time when those awake will understand how to make money in up, down, and surprise markets. Whether new trader or experienced, college student or financial advisor, protecting against a crash or just trying to make a lot of money, trend following offers everyone an answer in uncertain times. To get started immediately, send me an email, michael@covel.com. I will send you the right trend following steps to take along with my free video. But if you want to buy and hold, trust the government and trust Wall Street, this is absolutely not for you.